Hi everyone, myself Dr. Manjurata Singh, working as an assistant professor in the Department of Chemistry, RV College of Engineering, Bangalore, India. In this video, I would like to discuss about one of the very important biodegradable polymer, that is polylactic acid. Its preparation and the properties, and also how the mechanism involved in biodegradability, and also its various applications. Biodegradable polymers are the polymers which degrade quickly in aqueous medium in the presence of microorganisms. And the byproducts formed like carbon dioxide, water, methane, inorganic, they're all biocompatible and eco-friendly. Okay. And these polymers are actually degraded by simple hydrolysis of esters bond. We know that alcohol plus acid will give ester. If esters are exposed to water, it will come back to its original nature, that is acid and alcohol. Ester splits into alcohol and acid in the presence of water. That is very well-known reaction in organic chemistry. And that reaction does not require any enzymes to carry out that reaction. And also that degraded product prevents inflammatory reaction. That is another advantage. The hydrolytic products of this degradation process are then transformed, as I told you, into non-toxic subproducts, acts as a manure, etc. And also they are eliminated through normal cellular activity and urine if it is taken inside the body. Okay. And I'm going to discuss the polylactic acid as a biodegradable polymer, one of the most promising biopolymer produced from non-toxic, renewable, and naturally occurring organic acid, that is lactic acid. Lactic acid is actually obtained from sugar cane, okay, and it is one of the product. And this polylactic acid is a thermoplastic with good mechanical property profile that you can see. It has high biocompatibility, high biodegradable properties. And lactic acid is obtained from the fermentation of sugars. And we know that sugar is obtained from sugar cane, and it is a renewable energy, renewable resource. So therefore, polylactic acid can be produced in large scale and used as an environmental friendly biopolymer. Let us look at how it is being prepared. Polylactic acid is prepared by various polymerization process using lactic acid as a monomer. People have used polycondensation reaction and ring opening polymerization by using microwaves and using enzymatic polymerization, etc. So this is the slide representing the preparation of this is the polylactic acid, which is obtained from lactic acid. Lactic acid is actually obtained from sugar by fermentation. Lactic acid is actually a molecule which is having a carboxylic acid group, alcohol group attached to same carbon. This carbon is attached to one hydrogen that is not shown here, one carboxylic acid, one methyl group, and one OH. That is called lactic acid. When that lactic acid in a suitable solution is exposed to microwaves, it polymerizes itself within itself, and that carboxylic acid group of one lactic acid reacts with alcoholic group of another lactic acid, resulting in the formation of ester. Alcohol plus carboxylic acid will give ester. So polylactic acid is a ester. You will get high molecular weight polylactic acid when you use microwave for the reaction. Or if you carry out the polymerization between 200 to 250 degrees centigrade, you will end up oligomeric lactic acid, means low molecular weight lactic acid is going to form. And if you just increase temperature above 250, means about 260 degrees centigrade, this polymer undergoes cyclization. That oligolactic acid undergoes cyclization, leading to the formation of a lactide. So this lactide, again, if it is exposed to microwave at maintaining temperature of 130 to 150 degrees centigrade for 3 hours, you will get high molecular weight polylactic acid. So this is actual backbone of lactic acid. This is an ester, COOCH3 ester is formed. Alcohol plus acid forming ester. So this is a very simple organic reaction. This is how the polylactic acid is being synthesized. Now, next, let us look at how the mechanism of degradation of this polylactic acid. As I told you, alcohol plus acid will combine to form ester plus water. Okay, it's a reversible reaction that we study in organic chemistry. It means that when ester is exposed to moisture or water, it combines and results and produces alcohol and acid back. The same reaction is happening here. This is actually polylactic acid. You can see the ester group, CH3COO, CH3COO, CH3COO groups are present. When this polylactic acid is exposed to moisture, water, this is the lone pair of electrons of oxygen nucleophile, and the carbonyl carbon of the ester having delta plus charge because of electromagnetic effect. This carbon is partially positive because of oxygen, it will be partially negatively charged. Therefore, this will attack carbonyl carbon, and this bond is going to break. This bond is going to break down. As a result, this bond will break electrolytically and shift these electrons to this oxygen. Okay, and this oxygen abstract one proton from this, resulting in the formation of OH group, and this OH group is going to substitute in place of this carbonyl carbon. As a result, there is a cleavage of this polymer. You will get all acid, carboxylic acid, and alcohol are getting separated by adding water. Similarly, this low molecular weight polylactic acid keeps on degrading in the presence of water, finally resulting in the formation of some carboxylic acid and carbon dioxide, water, etc. So that is how the hydrolysis helps in breaking this polymer. This is the mechanism behind this degradation. This takes place even in the absence of enzyme. Okay. And next, let us look at the applications of this biodegradable polylactic acid. Polylactic acid are being used in tablets, coatings. These are all, when you take tablet filled with medicine, this will degrade inside the stomach, and it will come out through urine. Okay, these are all, this is all biodegradable polymer. Even for dental applications, screws, sutures, etc., they're all made up of polylactic acid. In tissue engineering, 3D electrospun fibers are scaffolds for bone regeneration they are using nowadays, and implants, fixation for fractured bones in the forms of plates, pins, screws, and wires are being developed by using this polylactic acid. And also drug delivery for microspheres, microcapsules, nanoparticles, RNA, DNA delivery can be carried out by using this biocompatible and biodegradable polylactic acid. A drug-eluting stent, bioabsorbable medical implants, sutures in the dermatology and cosmetics applications are in which this polylactic acid is being used. So this is PLA, polylactic acid implants, chitosan nanoparticles, modified functionalized polylactic acid. This is actually information which is taken from this journal. So Journal of Applied Microbiology. These are the applications of this polylactic acid biodegradable polymer. This is stitches, but this is biodegradable stitches. Okay. With this, I'm concluding my discussion. For any questions or clarifications, please email me using this email ID. Thank you for watching this video.